So we are going to discuss the next exercise, that is exercise 12.3. Let's start with the first question. Okay, whatever will be like easier or simple, I'll be leaving those questions for you and we will be continuing like that. I believe this exercise will take 2 classes. So today we are going to start it. Today I have already discussed that assessment will not be activated in your account. So in the next class, once we will finish this, then I'll tell them to just activate the assessment. Then you will be able to give the assessment related to this topic. So let's start. Okay, just the introduction or the first few questions we will be taking today. So here, this exercise is totally based on the concept of area of combination of plane figure. So here we will be having combination of figure. We know the figure rectangle, we know about square, we know about circle, we know about triangle. So here we will see combination of 2 3 figures. We have to identify those figure. Formula we already know about each and every figure, like rectangle formula, area formula, for square, for triangle, for circle, we have already discussed. So whenever we will be having 2 3 shapes like all mixed up together, the combination of 2 3 shapes, we just have to identify the shape, proper formula we have to apply, and we have to find the area of the shaded region. That's it. Okay, so let's take the first question. The first question, I'm just drawing the picture. I'm just drawing the figure. You can open your book in front of you and I'll be reading the question with that. Okay, so in the first one we are having a circle. Here, let me finish the figure. This is O, this is R, this is P, and this is Q. This is the shaded region. And this one is also the shaded region. Okay, just a moment. Let me read the information given over here. Okay, so here the information says find the area of the shaded region. We have to find the area of the shaded region. If PQ is equals to, here PQ is already given as 24 centimeter and PR is given as 7 centimeter, where we can see O is the center of the circle. Just a moment, no? So here PQ is already given. PR is also given as 7 centimeter. Okay. And what we have to find? We have to find the area of the shaded region. Now, if you will look carefully on this figure, can you identify that it's a semicircle like RQP? It's a semicircle. Can you see? This one is a semicircle because a chord passing through the diameter must divide the circle in two equal parts. So
Yes,
can we
ma'am.
see this R, Q, P? It's a semicircle. Yes or no? Right?
Yes, ma'am. Can you hear?
Yes, it's a semicircle. And we know angle subtended in a semicircle, this angle must be of 90-degree, right?
Yes, ma'am.
Yeah. So now we have to find the area of this shaded region. So rather than focusing on this complete circle, we can focus on semicircle. Okay. Where we know there is a right angle triangle whose side is also given, that is PQ is given as 24 centimeter. PR is given as 7 centimeter. So since we are having a right angle triangle, we can find the hypotenuse of this right angle triangle. So this is the side. Here we know this is 7 centimeter and we, yeah, this is 24 centimeter. Here we are having O. Okay. We can easily find QR or RQ by applying Pythagoras theorem, where we can write that hypotenuse square RQ square is equals to 7 square plus 24 square. And after calculating it, we will get the total diameter RQ, right? Now, from here, after getting the diameter RQ, can we say area of shaded region? Area of shaded region is equals to area of semicircle. Hi Madiha. Just now we have started with the first question from the third exercise, and here we are having combination of figures. So I have taken the first question at first only. So here we are, can you see? Here we are having a circle and we have to find the area of the shaded region. This is the picture. Can you see the mouse? This is the picture we are having. And here
Yes,
we
ma'am.
have to find the area of the shaded region. For finding the area of the shaded region, we can totally focus on this semicircle. We know this RQP, this is a semicircle because a chord is passing through the center, that means diameter. It's dividing it in two equal circle. Okay. Now I have taken the semicircle. There we can see we are having a right angle triangle, PQR. Okay. In this right angle triangle, two sides are already given in the question. This PQ is 24 centimeter, PR is 7 centimeter. That information is already provided in the question. We are finding the diameter, the hypotenuse of this right angle triangle, and that is also a diameter of this semicircle. So by that, we will apply Pythagoras theorem and we will get the hypotenuse of this right angle triangle. Once we will get the hypotenuse of the right angle triangle, which is also a diameter of the semicircle, we can find the area of the shaded region. But how? We can say area of the shaded region is the total area of the semicircle minus area of the triangle. Can we say from total area semicircle, if we will cut out the triangle portion, we will be left with the remaining part, right? The shaded part. Are you getting it?
Yes, ma'am.
So I'm going to write that area of the shaded region is equals to area of semicircle minus area of triangle, area of this right angle triangle. Okay, finding area of triangle will be very simple over here because right angle triangle we are having. So 1 by 2 times base times height. Base and height both are already given. How we will find the area? Let me write area of triangle. How we will find the area of the semicircle? That is the formula pi r square over 2. Here r we will get from r cube. Okay, is it okay to both of you? I am leaving
Yes.
the calculation part over here. All right,
Okay. Okay, ma'am.
let's move to the next question. This way only I'll be explaining all the questions and the calculation and everything I'll be leaving for you. Okay, so now the next question is, suppose we are having this shape. A circle is there. One more circle is there. And both are concentric circle. This is center O. Here we are having, this is 40 degree. Here A, here C is there, here B, and here D is there. And we have to find the area of this portion. This is the shaded region. We have to find the area of this region only. Okay, 40 degree angle is already given over here. Now, if you will look at it closely, this is, let me read the question. Find the area of the shaded region if the radii of the two concentric circle are 7 centimeter and 14 centimeter. So this is concentric circle. One center is there for both the circle, but the radius of the bigger circle is given, radius of the smaller circle is also given. So let me write it, radius of bigger circle is given as 14 centimeter and radius of smaller circle is given as 7 centimeter. And we have to find the area of the shaded region. Now, if you will look closely, if I'll separate, can we say we are having sector of the circle? For a smaller circle, we are having one sector, that is O, B, D. This is the sector where angle is known. And yeah, radius is also known, that is 7 centimeter. And we are having a bigger circle. There also we are having a sector. And the angle is same 40 degree. Here the radius is 14 centimeter. Now, to find the area of the shaded portion, can we say from the bigger sector, if we will subtract the smaller sector, we will left with the area of the shaded part, right? So here the name of the bigger sector is OAC, okay? And we can write area of shaded region is equals to area of shaded portion is equals to area of sector, the bigger sector. Area of the bigger sector name is OAC minus area of sector OBD. Yeah. Easily you will be able to find the area of the smaller sector. You will also be able to find the area of the bigger sector by using the area of the sectors formula, that is theta by 360 into pi r square. R we know already, theta we know already. So easily we will be able to find the area of the bigger sector. We will also be able to find the area of the smaller sector. Now we just have to find the difference between both the area, and then we will left with the shaded part area. Is it clear to both of you?
Yes, ma'am.
Is it clear, Madiha, Jasleen?
Yes, ma'am.
Okay, let's move to the next one. Now, number 3. Here, number 3 says we are having a pic. Let me draw the figure. And this is the shaded region. Just a moment. Let me keep it off. Can you both see the screen?
Yes,
Can you
ma'am.
see the screen, Madiha and Jasleen?
Yes, ma'am.
Yeah. So this is the shaded portion and we have to find the area of this portion. Now how we will find the area of this portion? Let me read the instruction given over here. It says find the area of shaded region if ABCD is a square of side 14 centimeters. So this is a square A, B, C, D. Here the side of the square is 14 centimeter. This is 14. We know this is 14 because it's a square. We know this will also be 14 centimeter. So each and every side will consist of 14 centimeter. Okay. And APD and BPC are semicircle. APD and BPC are semicircle. Here P is there. Yeah. APD and BPC both are semicircle. Now, if you will look at the semicircle, we have to find the area of the shaded region over here. Now, if you will look at the semicircle, can we say that this is the diameter of the semicircle? Can we say? Which is
Yes,
known to
ma'am.
us as 14 centimeter. Okay.
Yes,
From the area of the square, if we will take it out, the area of the semicircle, we will left with the area of the shaded portion, right? So area of shaded portion will be area of square minus area of semicircles. Okay. So area of let me write it. Area of shaded portion will be equals to total area, the complete area, that is the squares area, minus area of semicircles. So area of square is what? Side square. We already know the side. Area of square is what? Side square. We already know the side. Side is given as 14 centimeters. So we can say 14 square. That is the area of the square. Now, area of semicircle will be pi r square by 2. Okay, but we are having two semicircle which is exactly of same same measurement, so we can say into 2 because two semicircles are there. Okay, is it clear to both of you? R we already know because here we know diameter of the semicircle is 14 centimeters. So radius of the semicircle will be 14 over 2. That means 7 centimeter. So radius of the circle, like semicircle, we know. We are having two exactly same measurement semicircle. So we can write area of the semicircle into 2. Okay. Once we will do the subtraction, we will get the area of the shaded portion. Is it clear to both of you?
Yes, ma'am.
Let's move to the next one. Number 4. How we are having this? Okay. Here it's given as 12 centimeter. Here it's given as okay. This is O. Now then, let me write the name OAB. Here, let me read the question first. This is the complete shaded region. Everything is just colored. Everything. The whole triangle, the whole complete portion, everything, whatever you can see on the screen, we have to find the area of that portion. Okay. So how we will find the area of that portion? So here, let me read the instruction first. Find the area of the shaded region where a circular arc of radius 6 centimeter have been drawn with a vertex O. So there is a circular arc which you can see, and the radius of that circle is 6 centimeter. It's written over there, and has drawn with a vertex O of an equilateral triangle OAB of side 12 centimeter. So OAB is an equilateral triangle. Okay. And we have to find the area of the complete portion. So any idea how to find the area of this complete figure? Anyone? We can find the area of the equilateral triangle, that is root 3 by 4 a square. A we already know, side of the, this is the formula for area of equilateral triangle. Area of equilateral triangle, this is the formula for that. So root 3 by 4 a square, where we already know the side of the squares, that is root 3 by 4. Side is give the area of the equilateral triangle. Now we will also find the area of this circle. Okay. So if we know the radius 6 centimeter, then we can easily find area of the circle, that is pi r square. So pi 6 square. But when you are taking this circle, then there is one thing which we have to be careful with. What is that thing? When you are taking the total area of the circle, that means you are taking the total circle. Okay. But we don't need the total circle. We have to, much portion of the circle is not included over there, right? Right, Jasleen and Madiha?
Ma'am, can you
Everything in this circle is shaded already except that sector. Can you see? That
Yes, ma'am.
sector is not even there. This sector. Okay, let me draw it again. It's like this one. Let me show you. We are having a circle. It's like this one. But if you are taking out the area of this complete circle, that means you have to subtract the area of the sector, right? Are you getting it?
Yes.
From the circle's area, we have to subtract this sector's area. Can you see it now? Is the picture is visible to you?
Yes.
Okay, this is how total circle, sector, leave the sector. Total circle, let me draw, just show you this part. This is the total circle area which we have already found, that is pi r square. Now just exclude the sector. Just a moment. Yeah. Exclude the sector, it will look like this one. Just like this one. Okay. Are you able to see the bottom figure? This one. So here we have to exclude that sector. Now we know the area of the sector's formula, that is theta by 360 into pi r square. But do we know theta over here? Yes, we know theta over here. How we know theta over here? Because it's an equilateral triangle. So can we say this is 60? This is 60. And this is also 60. Can we say? Are you getting it?
Yes, ma'am.
So area of the sector, we have to exclude from total area. So let me tell you what will be the area of the shaded portion. Area of the shaded portion will be area of shaded portion will simply be area of triangle, area of equilateral triangle, which I have written the formula over there. Equilateral triangle plus area of the circle. To subtract the area of the sector of the circle. So area of sector, if you want, you can name the sector like O. Suppose this is the sector you want to take. So you can name the sector as OMN. So we are going to subtract the sector's area, that is sector OMN. Is it clear to both of you? One thing I want to ask with you, is it possible for you to change the time of this class at least once, like on any day? Is it possible?
For which time, ma'am?
Time we will be discussing, like we will figure it out which time is convenient to you and which time, because this is the only class where I face a lot of problems. So one day, for at least one day, I wanna try to shift your class either before or behind, and wanna check that everything is going well on that time or not. Okay. So
Okay.
I'll be informing the whoever plans everything. They will also just connect with you and will figure it out if that is possible. So one day we will try that. Okay.
Okay, ma'am.
Okay. So yeah, I told that area of the shaded portion will be area of the equilateral triangle plus area of the circle minus. Is it okay? Have you understood the concept, both of you? Jasleen and Madiha?
Yes, ma'am.
Okay, let's move to the next one. In the next question, it's also very simple. Number 5. Here we are having a square. Here a circle is there. Here a semicircle is there. Not semicircle. The one fourth part of the circle is there. This type of circle is there. From each corner of a square of side 4 centimeter. So this is a square whose side is given as 4 centimeter. So we can write 4 centimeter over here, with 4 centimeter over here, 4 centimeter over here, and 4 centimeter over here because it's a square. Now, just a moment. No, it says from each corner of a square of side 4 centimeter. Oh yeah, from each corner of a square whose side is 4 centimeter, a quadrant of circle of radius 1 centimeter is cut out. So from each corner, a quadrant of a circle of radius, this circle, it's a quadrant of circle, one fourth part of a circle, okay, whose radius is given as 1 centimeter, is cut, and also a circle of diameter 2 centimeter is cut as shown in figure. So the middle one is having diameter 2 centimeter. So again, radius of this circle is 1. Okay. Find the area of the remaining portion. Which portion area we have to find? We have to find area of this portion. This portion's area we have. Okay. You can see that from the total area of the square, if we will take out the 4 part from the corner and then the middle one also, if we will cut it down, we will be left with the shaded part, right?
Yes, ma'am.
Yeah. So we can say that area of the shaded part is equals to, let's write it, area of shaded part is equals to area of the square the total area, all the 4, this quadrant of circles area. So 4 times quadrant of circles area will be pi r square, is 1/4 part of a circle. One corner formula will be pi r square over 4. This one will follow the formula pi r square over 4. This one is also following the formula pi r square over 4, and this one is also 1/4 part of the circle. Okay. Just a second, no. Okay. So here we can take area of the square, the total square, minus this pi r square over 4, and each and every one is having the formula pi r square over 4 only. So we can say 4 times pi r square over 4, right? Minus this, the middle circle area, that will be pi r square. You know that radius of each and every circle over here is 1 centimeter only. Even the middle circle is also, they have tried to give the data in other form, that is diameter of the middle circle is 2 centimeter, but eventually the radius is 1 centimeter only, right?
Ma'am, we can't see your screen.
You can't see my screen. Is it visible now?
Yes, ma'am.
Okay, so I was saying that the middle circle is having the diameter 2 centimeters. So eventually the middle circle is also having radius 1 centimeter only, right? And area
Yes,
of the shaded part will be total area of the this square minus the four corner minus the middle one. That will give, by doing that, we will left with the area of the shaded part, right?
yes, ma'am.
Yeah. So this is how we will be able to find the area of the shaded part over here. Okay, let's move to the next one. Just a moment.